start कर दे.
Welcome everyone to the post-contest discussion of Codeforces round div 2 914. So let's begin with the problem A. I'm sharing my screen. Please do let me know if it's visible. It's visible, right?
Yeah,
Hello.
it is visible.
Yes,
Yeah.
yes.
Starting with the first question. This question, I solved this question using the Brutus method that's possible. So I'll explain that. So basically, it's given that you are given a chessboard which is of infinite length and width. You don't have specific like dimensions of the chessboard. Also, directly going to the test cases, you're provided with two integers a and b, which is describing the possible moves of knight. As we know in the general chess box, what do we have is that we move one tile in one direction and then two step in the other direction. So basically here we are substituting those values with a and b, like a tiles in one direction and b tiles in the other. So in my test case, the first thing that is given is a and b value. Next, I am provided with two different locations. That is the first position of the king in the chess box, and the second is the position of the queen. So what we are supposed to find in the question is that we need to find all the number of positions, like from where if I place the knight at that position, I'll be able to attack both the king and the queen. Like whatever, I have to find all the possible positions, like from there if I go a then b step or b and a step, in that way I should be able to attack both the queen and the king. So I've just tried to, I'm showing my code, what I have done. So basically, as we know, I have created a vector of pair of king and queen. Like we know there are 8 possible directions in when the king can move. Like if I say from A to B, if the knight has to reach the king in A plus B steps, that means if I go in the reverse direction, so from king to knight, it will also be a combination of A and B. So in that way, what I have done is that I have tried to find out all the possible 8 directions from the king's position, and also I have taken all the possible 8 directions from the queen position. So in that way, I have created a vector of pairs for king and queen. And then what I have done is that, so as to avoid the repetition of any same position, I have created a set of pairs, and I have done like for each and every position of king, I have changed the corresponding position of queen, and I've inserted in the set of pairs. And then whatever I'm getting the unique number of position, that's the number of possible positions where the king can be placed. So there may be some other optimal methods too, but yeah, this is what I did. It's clear.
Okay, fine. Manikaran will explain the next B and C. Manikaran, share your screen. Carry on.
Is my screen visible now, Baya?
Yes, it is.
So in the B problem, here they ask that you are given an array of n positive integers and a score. If your score is greater than or equal to a of I, then you can increase your score by a of I and remove a of I from the array. For each index I, output the maximum number of additional array elements that you can remove if you remove a of I, and then set your score to a of I. So the thing is that if you sort the array somehow and maintain the indexes of each and every element, then you can remove all the elements less than a of I. So what I have done is I have taken the input array as input and then taken those array into a vector pair in which the first element of the vector pair consists of the element of the array and the second element consists of the index. Now I have sorted that vector pair. Now I have maintained an array of n integers to store the answer and another array of n integers to maintain the prefix sum. So I have calculated the prefix sum, and then here I have used the two-pointer method. We know that if the current element is I, we can easily add up to all the elements up to I because they are less than the current element. So another second pointer, j will be equals to maximum of j comma I, and while j is less than n minus 1 and the sum up to the jth index is greater than or equal to the next element, we just increment the value of j, and then we store the answer for that particular index as j. Then we print the answer here. And when coming to the C problem, you are given an array of n positive integers. In one operation, you must pick some I comma j such that 1 less than or equal to I less than j less than or equal to size of the array, and then append the modulus of ai minus aj to the end of a. And our task is to minimize and print the minimum value of a after performing k operations. Now, three cases arise here. Three cases arises here. The first case will be when k is greater than or equal to 3. Let a1, a2, a3, and so on, a and be the given array. And in the first operation, we select a1 and a2. Then the array element will be absolute value of a1 minus a2, and the remaining will be as it is. And the second operation, we again select a1 and a2, and again absolute value of a1 minus a2 will occur. And in the third operation, we select these two elements. So the difference will be 0, hence the minimum element becomes 0. So if k is greater than or equal to 3, the answer will be equal to 0. And the two cases will be remaining when k is equal to 1 and when k is equal to 2. And for that, I have used this thing. If k is equal to 1, then let's suppose a1, a2, a3, and so on, and let this be our array. And there will be only n choices that we can, there will be only these choices that we can make. We can select a1 and a2, we can select a1 and a3, or a2 or a3. So the answer will be the minimum among all the array elements and the minimum among the differences between the adjacent elements when the array is sorted. Hence, we just sort the array and we take some minimum element as the first element. Then we find the minimum absolute difference between two adjacent elements in the sorted array. And the original task is to find how to solve the problem when k is equal to 2. When k is equal to 2, we'll just sort the array. Then we label the answer as the difference between the first two elements, or we can just simply write in 64 max or something. And then we do the same as we done in the k is equal to 1 case. Then when k is equal to 2, after taking the absolute difference of two elements, we can also subtract it with another element to get the minimum one. So here we use the lower bound function to find binary search for the smallest element in the array that is greater than or equal to the current difference. Here we have used a nested loop. Then the current difference will be equal to absolute value of a of I minus a of j. Then we store the index of the least element that is greater than or equal to the current difference in index. If index is greater than or equal to n, which means that the difference is greater than all the elements of the array, then we consider the last element of the array into the difference. Else we will consider both the elements at the index and the elements at the index minus 1 also. And we will just print the answer here.
Okay. Now I'll be explaining D1 and D2. Is my screen visible?
Yes, yes.
In the problem number D1 and the problem number D2, both were the similar questions, but only the constraints were different. For D1, it was 1000, and for D2, the value of n was 10 to the power 5. So in D1, the question was we have to make array A equal to array B. And the condition was that we can choose any subarray and pick the maximum value of that subarray and then equate all the values in that subarray to the maximum of that particular subarray. So for example, if we pick this particular subarray, the maximum value is 3. And we can propagate this 3 to the whole subarray. So the array becomes 1, 3, 3, 3, 4. So after doing some set of operations, we need to make this particular array equal to this one. What we have to give is only yes or no. In the first test case, if we see clearly, then we are picking this particular subarray and the maximum value is 3, and then we are making this particular value 2 as 3 because the maximum is 3, and then the array is equal to this particular array. But in second test case, if we pick this particular subarray and the maximum value is 4, then 4 can be propagated till here, but we can never make this particular value 2 as 3 because for 3 to reach here, the value has to be smaller than 3 for the whole subarray, but it is not. So it is not possible to make this particular value as 3. For the third number case, this case, we can simply propagate this 2 value to the whole subarray. Then the array becomes 3 and then 4 twos. And then we can propagate this 3 value till here. So ultimately the array will become 33322. So if you notice one thing, that firstly we are propagating the smaller values and then we have to propagate the larger ones. So suppose this was my array. We need to make this particular array equal to this one, 3, 2, and again 3, 3. So firstly, we'll pick the smaller values, that is 1 and 1. And we notice that there is no 1 in the array B. So we will not propagate these values. Then again, we'll pick the smaller ones, that is 2 and 2. And we notice that these values are 2. So either we propagate this 2 till here or this 2 till here. And why we are able to do so? Because the array in this particular subarray, the maximum value is 2. So clearly we can make the whole subarray as 2. So this particular index and this particular index can be changed to 2. Now our array becomes 3, 2, 2, 2, 3, 5 twos. But we needed to make these two values as 3 and this value as 3. So we will propagate this 3 till here and this 3 till here. Then our array will become 3, 3, and then these 2 and 3, 3. Certainly, we can do this particular method in O of n square approach. The solution would be simply this. First, we sorted the values of the array A according to their value and also stored the index because the indexes are very much important since we are considering the subarrays. And then we will be iterating according to the values in increasing order in C. The C array contains all the array values in sorted order. And then we will be propagating towards the right, and then we'll be propagating the value towards the left. And how we are propagating? Firstly, we are checking if this particular, suppose we are propagating the value 1 to the right and to the left. So how much can we propagate this value? I can propagate this whole value to the right because all the values are smaller than this value or smaller or equal to this value. But I cannot propagate it towards the left because this value 2 is greater than this value. So I can only propagate in this particular subarrays. Again, I simply again do for this particular index and then for this particular index, then I'll move on. Then till where should I propagate this value? See, this one is smaller than 2, so I can propagate this value till here, again till here, then till here. but I cannot propagate in the left direction since 2 is smaller than 3 is greater than 2. So I can make the whole subarray as 2. Now for 3, I can propagate it till the last of the array, but I should not propagate it till there because the maximum value that is needed is still index number 2. So I have to propagate it till here. So I have written it like this. If array of j is greater than equal to x, or b of j is less than equal to x, this p of j is the second array. I'm comparing this value to the value x that I am. So since this value is smaller than this, then I should break this part. So my array will, I'll consider only this particular sub. This was for the right side, and similarly, I will do this for the left side also. So this was the code for T1. It was n square approach, so it asked this particular question. But T2, if you see the constraints that the values are up to 2 into 10 to the power 5, and it will not be possible to run a n square approach in this particular question. But the approach is similar to what we have done in the D1 question. First, we will consider the smaller values and we'll go the bigger values. So how will we do this? I have done this particular question in O of n approach, and I have used or you may use a monotonic EU also. So, make you understand first. This I navigated the values. So the third test case was 32111, and the B array is 33322. So I need to propagate all the 2 values till here and 3 values till here. And if you notice that if I counter any larger value, then I cannot propagate any smaller values that I had encountered in the beginning of the array. So I'll maintain a monotonic stack. Firstly, I encounter 3. So I can propagate the value 3 to the right of the array. Then I encountered a 2. See, I can also propagate the value 2 to the right side of the array. Then I encounter a value 1. I can also propagate the value 1. But suppose if I encounter a value 5 and a value 6 over here, and the array is like 6 and 6. So the monotonic stack is clear, but as soon as I reach this particular index 5, see, I neither can propagate this value 3, nor 2, and neither 1. I can only propagate 5 towards the right because the values are smaller in the left side of the 5. And again, when I reach 6, I cannot even propagate the value 5 towards the right. I can only propagate the value 6. Similarly, when I iterate from the right towards the left, I'll again maintain a monotonic stack. Firstly, I can propagate the value 6. Okay, propagate the value 6 towards the left of this array, since 6 is the largest one. Again, I can propagate the 5 towards this particular subarray. So I put this into the stack. Then again, I can propagate the value 1 towards the left. But as soon as I reach this particular index, that is 2, I cannot propagate this value 1 towards the left because this value is larger than the value that I have encountered. So I'll delete this particular value and put 2 in my stack. Again, when I reach this particular index, I've encountered a larger value than 2. So I'll delete this value and append a value 3 into the stack. So basically, I am looking for what values in my stack I can propagate it towards the right, and for what values in my stack I can propagate towards the left. So if I try run my code, for this particular test case. Firstly, the stack is empty, and I've encountered a value 3. So I put 3 into my stack. This means that I can propagate this value towards the right side of that. I don't know till what extent I can propagate it, but I am sure that I can propagate it towards the right. See, this index and this index is equal, so I don't need to do anything. Now I have reached the value 2. So I'll insert it into my decreasing stack. But this particular index is not equal to this 3. But since 3 is in my stack, I can simply change this value to 3. I've changed this value to 3. Since I could have propagated 3 to the right side of the array. Now I've encountered 1. So I'll simply put 1 into my stack. See, since 3 was in my stack, so I could have propagated the value 3 till this position also. So I replace the value with 3. Now I reach this index. 1 is already there in my stack, so I will not append it again. But see this index, I have to make this value to 2. So it's 2 in my stack. Yes, it is. So I'll simply change this value to 2. But as soon as I have changed this value to 2, I cannot propagate this value 3 to the right side of this subarray, the right side of this array, right? Since I have reached a minimum, a value that is minimum than 3. So I have to delete this value from my stack. So the maximum value that I can propagate from the to the right side is 2. And again, 2 and 1. Now again, I've reached this index 1. And the value of that particular index in the array is 2. So I can simply change this value to 2 since 2 is in my stack. So I change this value to 2. Consider if this value was not 2 and it was 3. Then I could never have propagated this value 3 till this particular index. Since there was a value that was smaller than 3 in between this subarray. And so 3 is not in my stack. Now I have reached this particular index. But what I'm doing is I am appending the larger values into the stack to maintain its monotonicity in a decreasing order. But see, if I append this 5 into my stack, then my monotonicity is not there. So I have to delete all the values that are smaller than 5. So basically I deleted 2 and 1. That means that neither I can propagate 2 towards the right side of this particular index, or I can propagate 1 towards the right side of this particular index. So what I can propagate is only 5. So I put the value 5 into my stack. But see, these two values are not equal, so I cannot do anything at this particular index. So I'm leaving it like this. Now I have reached 6. So I can propagate 6 to the right side of this particular array. Since there is nothing, so I simply delete it and put the value 6. And these two values are also same, so I don't need to do anything. So for my left to right iteration, my final array looks like this: 3 double 3 double triple 3 double 2 5 and 6. This array has changed to this, but now also my A array is not equal to my B array. So I will again do a right to left iteration and with the same logic. So I am maintaining a stack. Firstly, I encounter a 6. So I put this value into my stack. And then I encounter a 5. Since 5 is smaller than 6, I can put this value 5. Which means that I can propagate this 6 value to the left side of this array. And I can also propagate this 5 value to the left side of this. Now, see, I am at this particular index, and this value is not equal to this one. But 6 is there in my stack. So I can replace this value with 6. And again, if I keep applying this algorithm, nothing will change. And since these two arrays become equal, I can stop my algorithm till here. So that was the logic behind this particular question. And the code is pretty simple. This 4 5 lines is the only code that you need. I've created a DQ because there are some operations that I need to do in my stack from the that like removing values from the left and removing values from the right. So I'm maintaining a DQ for that. And this was the condition for popping the elements from the right, and this was the condition for popping the elements from the left. And then I simply appended the value firstly in my DQ and just checked if this value is present in the DQ. And I can replace the array index I with bi. And I have to do this for one left to right iteration and again for right to left iteration. If finally my array A becomes equal to my array B, then I have to print yes, otherwise no. So this was the solution to T2. I hope you would have understood.
I'll share another solution like what Ayush explained. That is like the most optimal solution of this question, I guess. And like even the code is also simple. But there is another solution available for this same question. Let me know if my screen is visible. Hello, Ayush.
No, it's not visible.
या आई नो तुम मेरा कोड खोल सकता है क्या एक बार स्क्रीन शेयर करके कर तो एक बार
चल रहा है क्या?
मेन कोड में चला जा
एक सेकंड.
So yeah, this question can also be solved using segmentary, where basically we maintain the positions of A and like B arrays. And basically what we do is initially we move from smaller elements in B to larger elements in A while filling the smaller B elements in A slowly and slowly. And that is that for loop from 1 to n and then iterating on the positions in B which are not matched. Suppose it is not matched, there we can use binary search plus segmentary actually. In the binary search part, we basically see that till how much left from the position of not match we can go. And this for this we need to check is that if there are positions which are matched, because if there is a matched position since from before and then we overwrite it, then it will like distort the array and then things won't match. So we need to check at first that if there is already um, matched pair or not, that we can use by one segmentary. And the another segmentary we can use is to check if the maximum in that range is equal to B mid or not to match that thing. For left we check it once and for right we check it once, and thus if there is an possible way, then basically we put it and we update our segmentary. Though this code is like a bit complicated, but this is a good solution to understand segmentary, and even here we need to use lazy propagation. So this is a good question to understand those type of questions on this. So yeah, that would be my solution for D2.